Hi guys, today I'm going to go over questions 21 through 25 from the 2017 AMC 8. Timestamps to each question will be provided in the description. Suppose A, B, and C are non-zero real numbers, with A plus B plus C equaling 0. What are the possible values for A over the absolute value of A, B over the absolute value of B, C over the absolute value of C, and A times B times C over the absolute value of A times B times C. Okay, so we have two cases here. First of all is 2 negative and 1 positive. Second case would be 2 positive and 1 negative. So let's do this case first. Case 1, 2 negative. Let's say -1 and -1. And 1 positive, let's say 2. Let's say this is A, B, and C arbitrarily. Then that would be -1 over 1 plus -1 over 1 plus 2 over 2 plus 1 times 1 times 2. That would be 2 over the absolute value of -1 times -1 times 2. That would be 2. So this equals -1 plus -1 plus 1 plus 1, and that equals 0. Let's do the second case now, where there are 2 positive and 1 negative. So 1, 1, 2 arbitrarily, or no, not 2, -2. And let's again arbitrarily assign values to each of those numbers. So we would have 1 over 1 plus 1 over 1 plus 2 or -2 over 2 plus 1 times -2. That would equal -2 over the absolute value of -2. That would be 2. So that would equal 1 plus 1 plus, or minus 1 minus 1. So this would equal 0. So the answer is A. Question 22 states, in the right triangle ABC, AC equals 12, BC equals 5, and angle C is a right angle. A semicircle is inscribed in the triangle as shown. What is the radius of the semicircle? Okay, well first of all, let's make the semicircle into a full circle. So this, and let's draw the rest of the triangle. Let's label this point as D. Okay, from here finding the radius of the semicircle is pretty easy. All you have to know is that the area of a triangle equals the semiperimeter times the in radius. And what is the in radius? It's just the radius of the inscribed circle. So this. And that's exactly what we need to find. So we can calculate the area of this triangle first. The area of this triangle is 10 times 12 over 2, because this entire length is 10. This height is 12. So that equals 60. So 60 equals the semiperimeter. What is the semiperimeter? Okay, well, this AB and AD both equal 13, because this is a 5, 12, 13 right triangle. So the semiperimeter would be 13 plus 5 over 2, and that equals 18. So 60 equals 18 times the radius. So let's divide 60 by 18, and that equals 10 over 3. 10 over 3 is the radius of the semicircle, so that's D. Question 23 states, each day for 4 days, Linda traveled for 1 hour at a speed that resulted in her traveling 1 mile in an integer number of minutes. Each day after the first, her speed decreased so that the number of minutes to travel 1 mile increased by 5 minutes over the preceding day. Each of the 4 days her distance traveled was also an integer number of miles. What was the total number of miles for the 4 trips? Okay, so we know that the number of minutes it took for her to travel 1 mile increased by 5 minutes every day. So let's write that as the first day it took her x minutes, the second day it took her x plus 5 minutes, the third day it took her x plus 10 minutes, and the fourth day it took her x plus 15 minutes. Now let's think about this in terms of the distance equals rate times time formula. So let's think about the first day. Each day for 4 days, or let's think about how we can write the rate. So rate equals distance over time. So every day she's traveling for 1 mile in an integer number of minutes. So her rate is 1 over her time, which always varies. And for each of the 4 days, the distance traveled was also an integer number of miles. So what was her total number of miles for the 4 trips? Well, every day, because she's traveling 1 hour, this is just multiplied by 1, and that has to equal the, distance. So basically, what we're looking for is 60 over x, because 1 hour turns into 60 minutes. So what we're looking for is 60 over x plus 60 over x plus 5 plus 60 over x plus 10 plus 60 over x plus 15. And we're looking for this to be an integer. And each of these terms has to be an integer. So the only value of x that always consistently gives us an integer value for each of the terms is when x equals 5. So this equals 12 plus 6 plus 4 plus 3, and that equals 25. So the total number of miles for the 4 trips was C. Question 24 states, Mrs. Sanders has 3 grandchildren who call her regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. All 3 called her on December 31st, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? Okay, let's think about this in terms of what is the smallest multiple, or the least common multiple. How many least common multiples can fit into 365? So there are one that calls every 3 days, one that calls every 4 days, one that calls every 5 days. So here we can see that the least common multiple of this is 60. So let's think about the first 360 days first and think about the rest, or the other 5 days later. So out of those 360 days, 2 out of 3 of those days no one calls, or her first grandchild doesn't call. 3 out of 4 days her second grandchild doesn't call, and 4 out of 5 days the last grandchild doesn't call. So multiplying all this out, we get that this is 144. So there are 144 days where she doesn't receive a phone call from any of her grandchildren. Now let's think of the last 3 days, or last 5 days, 361, 362, 363, 364, 365. So she definitely gets a call from her grandchild on this day, because that's divisible by 3. She definitely gets a call from her grandchild on this day, because that's divisible by 4. And she definitely gets a call from her grandchild on this day, because that's divisible by 5. So there are only 2 additional days where she doesn't receive another phone call. So 144 plus 2 equals 146, or D. Question 25 states, in the figure shown, US and UT are line segments each of length 2. And the measure of angle TUS equals 60 degrees. Arcs TR and SR are each 1/6 of a circle with radius 2. What is the area of the regions shown? Well, first of all, let's draw in those sectors. So let's draw in that bit of circle here. So if TR and SR are both 1/6 of a circle, the angle also has to be 1/6 of the angle. So 1/6 of 360 is 60. So this angle has to measure 60 degrees, and this angle has to measure 60 degrees. And we also know that TUS equals 60 degrees. So this is an equilateral triangle. We also know that this has a radius of 2, US equals 2, TU equals 2, radius of 2, radius of 2, and radius of 2. So basically what we can do now is we can find the area of this equilateral triangle and subtract the two little sectors from that area. We can subtract this and this from the area of the equilateral triangle to find the area of TUSR. Okay, so what would the area of the equilateral triangle be? It would be, because this side length is 4, the side length squared times root 3 over 4. So 4 squared root 3 over 4 equals 4 root 3. What would be the area of these little sector chord things, or not chord, sectors? That would be, let me choose a different color. That would be, together they are 1/6 of that triangle, so they are 1/6 of that circle, so 1/6 of the total area of the circle, which is 2 squared times pi, equals, and then you would multiply by 2 because there are 2 of them, equals 4 over 3 pi. So the little chord thingies equal 4 over 3 pi. So the area of the region shown would be 4 root 3 minus 4 over 3 pi. That would be B. Thank you so much for watching. Stay tuned and subscribe for more math content in the future.